After playing around with the Arduino a bit, Katherine and I decided that we really need to buckle down and start building the actual instrument pack that we would be flying.
Wiring up the Arduino up to a breadboard is fine for bench work, but we are expecting this flight to have at least a few bumps.
Balloons are supposed to be gentle.
We needed to be able to mount several components to the Arduino, and we couldn't do that with the main board. However, the Arduino is designed to have other boards stacked onto it. The other boards are called shields.
We decided to build our own board, starting with a protoshield. The protoshield starts out as a fairly empty board.
But buying it pre-assembled? What's the fun in that? We bought the kit so we could solder it together ourselves.
Since this was Katherine's first time with a soldering iron, we did a couple of practice runs, soldering two pieces of wire together.
Here I am tinning the iron. Basically, I'm coating the tip of the iron with a little bit of solder to make it conduct heat more efficiently.
Next, we went through the assembly tutorial found on SparkFun, and we began with the resistors.
Mwahahahahahaha. Resistance is futile.
Actually, it's required here.
Oh, okay, never mind then.
We placed the first resistor in its spot and bent the leads a bit to make sure it wouldn't move while we worked on it.
Then, we applied some solder to the joints. We repeated the process for the other two resistors on the board.
I was a little worried about how well we managed to attach the resistors, so I pulled out my multimeter to test them.
Two of the resistors were 330 ohms, and the third was 10,000 ohms. Using the multimeter, we tested the unsoldered joints on the board that were connected to those leads. If the multimeter showed the resistance of the components, then we would be confident that the joints we soldered were solid.
And they were. All three resistors tested out just fine. Oh, and pay no attention to the other components you see on the board in this picture. They weren't there when we tested the resistors, honestly. Just a little movie magic time travel. Nothing to see here.
Next up were the two capacitors. One of them had a bit of solder stuffed in the hole already, so we had to get a little creative with that one. The second one went in without nearly as much trouble.
Next, Katherine attached the first LED. I tried to test the first one, and I think I burned it out by putting too much voltage through it. Yep, definitely looking a little crispy there.
Next, we attached the second LED, the two switches, and the four headers. Attaching the headers was definitely a team effort. Dad held the header in place, it had to be straight up and level, and used the soldering iron. I applied the solder. We ran out of time before we could completely solder the headers in, but at least they are physically attached now.
On a separate night, because this board did actually take us multiple sessions to get through, I was able to get the burned out bulb removed, but in the process I pulled up part of the circuit board. I decided that A, I just can't win with this, and B, I'd leave that for later. I also finished soldering in the headers, and then tested them with the multimeter. I set it to measure resistance, and then hooked up a cable to each header pin. Then, with the other lead of the multimeter, I tested the connection right beside the header pin. Without touching the board, the resistance would register as 1. If everything was hooked up properly, the resistance should drop to 0, which it did for every pin. So, we've tested most of the individual components on the board. I then asked Katherine how could we test the board in a more comprehensive way. Without hesitation, she replied, "Hook up Blink again."
So we did. Well, okay, technically we hooked up Stoplight, which is our version of Blink, but modified for 3 lights, and it worked beautifully. Well, that concludes the work on the shield itself. Next, we need to map out where each of the components for the instrument pack will fit onto the shield. Then we can get down to attaching them and writing the sketch to control them. See you next time!